welcome to this short presentation by the Institute for Conscious Global Change on the need to add GIS support to the United Nations Sustainable Development Goals. At the Rio+20, the UN Conference on Sustainable Development, countries agreed to establish an intergovernmental process to develop a set of action-oriented, concise and easy to communicate sustainable development goals to help drive the implementation of sustainable development. The Rio+20 outcome document, The Future We Want, also calls for the goals to be coherent with the United Nations Development Agenda beyond 2015. A 30-member open working group of the General Assembly is tasked with preparing a proposal on the SDGs. This presentation supports and augments the compendium of statistical notes for the Open Working Group on Sustainable Development Goals. We applaud the data-driven approach towards poverty eradication adopted by the Open Working Group. Starting with some 17 general goals, the current working document identifies 30 targets, which in turn are represented by 100 indicators. This is a subset of the targets listed under Goal 6, Secure Water and Sanitation for All. You see that the targets are ranging from pretty generic, universal access, to pretty specific, improve certain functions by a given percentage. Each indicator in turn is formalized as a measurable outcome, as here on this slide, where the success in water resource management is measured as the percentage of water extracted over the total amount of renewable water resources available. As a side note, this measure is already a nice example for our concern here. The amount of renewable water resources available is a function of the area covered. Just because water is available in, say, Nigeria, does not mean that it is available in a sustainable amount in a northern province located in the Sahel. This presentation speaks in particular to Goal 17, which deals with the implementation of other Sustainable Development Goals. On the left-hand side, you see traditional requirements that we all support, but I would like to draw your attention to two targets. 1726, to promote regional and international collaboration on and access to science, technology, innovation, research and knowledge sharing, including through North-South, South-South and triangular cooperation. 17.36, by 2020, substantially strengthen capacities for data collection and statistical analysis relevant to sustainable development with a focus on generating timely and high-quality data disaggregated as appropriate by income, gender, age, race, ethnicity and rural-urban location. These two targets speak directly to the mission of the Institute for Conscious Global Change. We need to first provide general access. That is, access to open data and to freely available tools, say in form of open source software and web services, that allow a bottom-up approach to the collection of data in support of the Sustainable Development Goals. The current draft of the SDSN report mentions geography 3 times, more or less in passing, and mostly as one of the many ways of disaggregating data. This is disappointing because even the original Rio+20 document specifically recognizes the importance of space technology-based data, in situ monitoring and reliable geospatial information for sustainable development, policymaking, programming and project operations. The United Nations Statistical Commission, friends of the Chair Group on Broader Measures, and other relevant UN agencies compiled a compendium of statistical notes for the Open Working Group on Sustainable Development Goals, which details in 8 paragraphs spread across the document the need for geospatial data. Which begs the question, What is geospatial data? In short, geospatial data is any kind of data that has a reference to a location, be it XY, lat long, addresses, or any kind of geographic unit that has a well-defined extent, such as a county, a national park, or census district. I will briefly go over examples for each of these on the next couple of slides. Locational references come in form of coordinates, either XY or latitude-longitude. We all know XY from our traditional geometry or the graphical depiction of some statistical data. It is the same here, except that the XY now refers to a particular location on the surface of the Earth. Depending on how the data was captured, or if we want to avoid the distortions that come from projecting the surface of our planet onto a plane, we sometimes also use locational references given in degrees, latitude and longitude. What many people do not realize is that there are many other, less abstract forms of locational references. Addresses are a common example, or distances from well-known points resulting in a form of triangulation, as on the figure on the right. Probably most common, when we are talking about statistical data, is the reference to well-known areas. These could be census area units, administrative boundaries, national parks, postal codes, etc. There are two traditional major sources for geospatial data. This slide here depicts data derived from satellites. Satellites do not discriminate boundaries, but give us reflectance values, which can or have to be interpreted by experts, about every square kilometer